Okay, so tell me, what could be the answer of the second question? What is Tyndall effect? What is the answer of this? What could be the answer? Respond.
So can you explain the question once?
I should explain it? No problem. So the question is the phenomena of a scattering of light by the colloidal particles give rise to Tyndall effect. Okay. So are you aware of Tyndall effects?
Yes, sir.
Okay. So it is being said that it is because of a scattering of light. The color of a scattered light depends upon the size of a scattered particle, whether this is true or not. Whether this is true or not.
Sir, option A.
Actually, it's not explaining the phenomena. Clear? It's not explaining the phenomena actually. Think why. Have you revised the Tyndall effect?
No, sir.
Okay, so it's because that the reason that it says there mm, is the color of a scattered light. In Tyndall effect, you might be having different type of color spectrum, but it is not because of that. It is because of uh, what the bending of lights. When lights goes from one medium to another medium, there is a scattering, and what can I say? In reflection as well. So it is because bending of light, not on the what can I say, size of scattered particles. Clear?
Yes, sir.
So give me 1 second. We have two more questions. Answer these two questions. Visible?
Yes, sir.
It's tough to memorize now which one is reason and which one is assertion. What happened? No answer. Madhya, what is your response? Normal human eye can clearly see all objects beyond a certain minimum distance. That's right. The human eye has capacity of adjusting the focal length of eye lens. That's
Yes,
called
sir. True.
That's called the power of accommodation. So what could be the option? Means, reason and assertion both are correct. And do you
Yes,
think
sir.
that,
Both are correct.
and do you think that this explanation is valid?
Yes.
Okay. So both are true, and this may be the correct explanation. And tell me, what about the next one? The next reason. That means that, tell me the next question. Respond. I'm not gonna give you much hints. Okay. You have to solve the think and do. Madiha is not responding at all.
Sir, I just responded.
Oh, it was you. Okay. But
Yeah.
very few questions.
Yeah.
What about this one? What about this question? Because I think you have already prepared well for your exams. So now it's your turn to just give the response and one after one.
Sir, I guess both are correct.
Okay. Both are correct. So why you think both are correct? Why do you think both are correct? There might be some reason, na? So a rainbow is sometimes seen in a sky in rainy season only when to observer back is toward the sun, right? Internal reflection in water droplets cause dispersion and the final rays is blocked. Internal reflection in water droplets cause the dispersion and the final rays are backward direction. So how was the process? Anyone remember? Can you draw the graph? That was ray diagram for it. Clear?
Yes.
So can you draw the ray diagram and see?
Yes, sir.
Okay. Check that. How was that possible? Right on this. Mhm. The option A is correct. Okay. I think I can't write it over here. So going back to OneNote, there we may write something. It is like I'm drawing the graph over here. This is the droplet and sunlight is coming from here. Okay. And if you will stand over here, keeping eyes this side, the sunlight is coming from backward, sun is over here somewhere. So the light will come and it will come to your eyes. So there is the option A is correct for this problem. Internal reflection in water droplets causes dispersion and the final rays are in the backward direction. So final rays are in the backward direction. Clear?
Yes, sir.
So you guys are not responding much. It means you didn't understand well.
No, sir. I understood now.
Okay. Clear. So what about this fifth question?
Sir, option A.
Okay. So Madiha, do you have to make any comment on it?
No, sir, it's correct.
It's correct. Yes, it's correct. Madiha is on safe side. Okay, what about the question number 6? What the correction of hypermetropia?
Option A, sir.
Option A. Do you think hypermetropia is being corrected by converging lens? Hypermetropia. It says answer B.
Yeah, it's corrected by the convex lens.
Okay, so hypermetropia is being corrected by convex lens. So sometime I think that you guys are having good revision, but when I face you, I too lose my confidence. Why happens? Why are these? Why is this situation? Hypermetro is being myopia is a converging lens and hypermetropia is con
Convex lens.
let me put it over here so you keep in the mind. Is this visible?
Yes, sir.
So this is the case of hypermetropia. Oh my gosh. Convex lens. This is concave lens or convex lens? This is which type of lens? Yes,
Myopic. Myopic.
yes. Myopic. Which type of?
eye can be corrected by the concave lens.
The concave lens. So this option is okay. Should we move further?
Yes, sir.
Okay, what about the 8?
Sir, option A.
Option A. Why?
Because there is no oxygen above, like in the outer space, so the light can't scatter.
Good. What about the next one? Twinkling, twinkling, little star. What about this? Stars twinkle while the planet dawns. Reason is the stars are much bigger in size than the planet. But what is your intake? It's not the correct statement is okay, but it is not the correct explanation. It is not the correct explanation. Clear?
Yes, sir.
What about the next one? What is the reason for the question number 10?
Sir, option A.
Option A. It is because of atmospheric friction, right? So almost we did 10 questions. What about numericals?
Sir, there are no numericals in this chapter.
Have you solved all the exercise numericals?
Yes, sir.
Okay. So we already done with electricity. We already done with electricity. So we can move to the first chapter, light, light reflection and refraction.
Yes, sir.
Okay. So Madhiya, tell me what is light?
Light?
What is light? Revision of the chapter, revision, light, reflection, and diffraction. Diffraction. What is the light, reflection, and refraction? Three terms. All these three terms need explanation, you know? These are very important terms. Can you explain these terms?
Light is something like when it enters our eye, we can see the things around us.
Yes, good. What about reflection?
Mm,
What about reflection? What about refraction? What about reflection? Recall, Madhya, you, what is your response? Reflection. So, suppose this is a glass slab, and we draw a normal on it. Clear? This is normal. A light is coming and is striking the surface at over here. Okay. So what does this angle being called? What is the name of this angle? You have to tell me each and everything.
Angle of reflection.
Okay. Angle of reflection. So what about this one? What about this one?
Sorry, the other one is angle of incident, and this one is angle of reflection.
Let's say, so you say that other one, this one.
Yes,
This is
sir. This one is angle of reflection.
reflection. Reflection, not refraction. Right?
Yes, sir. I told reflection, sir.
I heard that you were saying like that. This is called incident ray, so it is incident, right? Incident angle I, and this is called reflected angle. And this is also called the refracted angle. So in case angle I is equal to angle R, angle I is equal to angle R. But this is called the refracted rays. Okay. So,
Yes.
so if you will write the, do you remember Snell's law? Snell's law, this is N1 and this is N2. So this time we are doing revision. So there is no need to follow the structure, okay? We can bring the concept in between as well. Any of you see, this is the first law is this one. That first law is incident ray, reflected ray, and normal. All three lie in the same plane, right? Same
Yes,
plane.
sir.
And angle I is equal to angle R as well. But the second point is Snell's law. You have to remember it. So this is, we can write it N1 sine incident I. This will be N2 sine R. Madiha, it's too late in your Lucknow, right?
Yes, sir.
Are you sleeping?
No, sir, my laptop is not working properly, so it's barely unmuting the mic.
Okay. So what is the N1 and N2? What is N1 and N2? I just told you na. What is N1 and N2? What is N1 and N2? What is N1 and N2? It is called refractive index. Refractive index, right? And what
Yes,
is
sir.
refractive index? Question is not going to be over. What is refractive index?
When light travels from one medium to another medium.
Right. One medium to another medium. From rare medium, you say rare to denser. Okay. Or you say that from vacuum to denser. Then its speed, then its speed decrease by a factor. Decrease by a factor, that is n, called refractive index, Ri. So that is when you will see C over V, it will give you n. So C is n into V. This is the refractive index. And also when light from one medium to another medium, or you may say rare to denser, it bend toward the normal, right? The bending of light is also happens when it move from one head to one medium to another medium. Clear?
Yes, sir.
So there is one term, refractive index, and other than is relative refractive index. There is some term called relative refractive index. Are you aware of it? Or it is just coming in mind? Relative refractive index. Relative refractive index refers to the speed of light when it changes medium. The rate of light's speed changes as it comes from one medium to another medium. This change is the refractive index. Okay, this is the relative. Okay, this is C or V is also called relative refractive index. Relative RF. Refractive index, RFI maybe. Okay, so what is the dimension of this refractive index? Can you tell me the dimension? What is dimension of this N? What is the dimension of n? It is also called a specific as well. A specific. What is the dimension of n? Tell me. Dimensionality of n. So before that, if you are not able to recall, can you tell me what is the dimension of DIMEN? What is dimension of V? What is dimension of V? Means V is a velocity. What is dimension of velocity? It is compulsory to answer.
Displacement. Displacement into time.
Displacement into time is velocity. Displacement divided by time. Velocity, what is the definition of velocity? Displacement over DISPLACE, displacement over time. Okay, so this is displacement is length L of T inverse. This will be the dimension or dimensionality, or you may say that meter per second, right? C is also the speed of light. C is called speed of light. The speed of light. What is the value of C? Will you tell me what is value of C? What is value of C? What is the speed of light? You guys are not doing revision at all. What is value of C? The speed of light is too much. 3 into 10 to the power 8 meter per second. So both are the velocity. So ratio of velocity over velocity has no dimension. So this refractive index N has no dimension. Okay, so it has no dimension. So it has no dimension. So what you guys are doing? You are aware of dimensions, na? I hope you will study and we will resume from the next time. We will start from here only, right? If you have any doubt, you may ask. If you have any doubt, you may ask. Any doubt? Okay, so if I am giving you a numerical, this is numerical. When light passes through a thin glass slab its velocity become 2 into 10 to the power 6 meter per second. Find the diffractive index n. Do it. Did you solve it? Did you solve? Did you get the results? Madhya and Jacqueline, sorry, Tejasvi, any improvement? So it will be simply n will equal to what? C over V. C is 3 into 10 to the power 8. And this is 2 into 10 to the power 6. This will be like this. Did you get answer? I hope you guys are doing. Okay, then